Hello students. In this lesson we're going to use the tangent line to a curve to approximate a function. In particular, we're going to approximate the square root of 4.1. The function is the square root of x, and what we're going to do is find the line tangent to the square root of x near this point, 4.1. And the most obvious point probably to use would be the perfect square 4, because the square root of 4 is 2 and it's easy to compute. All right, let's get started. So here's the idea. We have this curve, the square root of x, which is red, and we have this tangent line. And you can see that the line tangent to this curve at this point, 4, 2, is a pretty good approximation. In fact, if we were to zoom even more, if you really look closely here, it's hard to tell the difference between the tangent line and the curve. And that's the concept behind this process. So here's the idea. We're going to use the tangent line to approximate the function close to this point of tangency. Okay, so let's approximate the square root of 4.1 using the tangent line near x equals 4. Here are our two options for the equation of the tangent line. So we have to figure out x naught, y naught, and m tan. We already know x naught. We're going to use 4, x equals 4, as the value where the tangent line and the curve will intersect. Now, this will work good. This will work well for perfect squares like 4, 9, 16. If you need something that is not a perfect square with the square root function, for example, like if you wanted 2.5 or 11, the square root of 11, or something like that, you would need a different approximation process. This approximation process will work particularly well for perfect squares. All right, so here's f of x equals the square root of x, since that is the function that we're going to approximate. Now, the derivative of the square root of x is 1 over 2 root x. That'd be a good one to commit to memory. And the reason that I'm writing it this way is that it's, that square root of x appears in the denominator again, and that's easy to compute. I'll show you how we get that 1 over 2 root x in the next few moments here. But that's a good one to commit to memory, and that's the form of the derivative that I'll use for the rest of this lesson. Okay, so let's see how we got that. Recall that, right, the square root of x is x to the 1/2, so we bring down the 1/2, we subtract 1 from 1/2, and we get minus 1/2. And so then x to the minus 1/2 is 1 over x to the 1/2, and then x to the 1/2 is the square root of x. All right, so just a quick reminder on how we got that. All right, so let's move the 2 over there because the square root of 4 is 2. And then to find the m tan, that's f prime of 4. Recall that, again, you can put the 4 into two places, right? So to get the y naught, to get the y value, you put it into the original function. Yes, the m tan is the derivative, right? That the derivative is a function that outputs slope, and in particular slope of tangent lines to curves. And so once we plug the 4 in to that square root of x that's in the denominator, we'll get the square root of 4 is 2. So let's put that in. And then 2 times 2 is 4. And so the slope of the tangent line is 1/4. And so let's put that in. So now we got that. But since we have that information, let's put it into our equation of the line. So there we go. And the 1/4 can also go into that form. Now we just need to find the y-intercept. Now keep in mind, this b here, this is the y-intercept. That's not this value here, 2, right? Because remember that the y-intercept occurs when x is 0. And here, x is some general number. So here's what I'm saying. X equals 4 is our value where we have our point of tangency, 4, 2. Here's our square root of x curve. Now we have our tangent line. It's 2 plus 1/4 times the quantity x minus 4. So what I'm saying is that this line, this equation of the line, is an approximation to the square root of x near x equals 4. What we could change this form of the equation of the line into the mx plus b form. But to do that, we'll have to set x equals 0 to find what the y-intercept is. So we need to find this value here. So let's go ahead and do that. So the y-intercept is when we put x equals 0 in. So let's simplify that. And 0 minus 4 is minus 4. Minus 4 times 1/4 is minus 1. 2 minus 1 is 1. And so now that we have that value, we have b is equal to 1, because b is the y-intercept. And so we have 1/4 x plus 1. Okay, so let's now, we'll use this approximation to instead of this one, because maybe this one is has less less going on, right? Less operations to worry about. So instead of this form, we'll use this form. So these are equal to one another, and so what we're saying is 1/4 x plus 1 is approximately the square root of x near the value x equals 4. Okay, so let's use that approximation. We'll plug the 4.1 in. So instead of computing the square root of 4.1, we'll compute 1/4 times 4.1 plus 1. And we'll see that that calculation is 2.025. If you want to do this as a fraction, think that 4.1, well, that's in the tenths place. So that's 41 over 10. So 1/4 times 41 over 10 is 41 over 40. I changed the 1 to a 40 over 40, so I have 81 over 40. So 2.025 is 81 over 40. Notice that if I plug 4.1 into my calculator, right, and calculate the square root of x, I get 2.0248 and some other decimals. And I only went to 3 decimal places. So if you actually round up, right, with this 8, you do get 2.025. So this is a pretty good approximation, this line here. It's a very good approximation to the square root function near 4. All right, so anyways, that is how you go about finding this, what we call a linear approximation to a function. So here's one example of how to do that. All right, good luck.